We have seen how numbers evolved from Stone Age to primitive civilizations to our modern number system. Our modern number system uses only 10 digits. And we have seen that after these 10 digits, we started counting numbers and we came to natural numbers. Well, after the addition of 0, we call these natural numbers as whole numbers. When I tried out addition in whole numbers, we saw that whole numbers were closed under addition, but they were not closed under subtraction. So to enclose this subtraction, what I did is I expanded my number system. I included the negative numbers, and after the inclusion of negative numbers, the whole numbers with the negative numbers came to be known as integers. Now in integers, we've seen that addition and subtraction both were closed. Also, integers were closed under multiplication too. But when we moved on to division, we've seen that division could not be expressed. Every time division was not able to express the result through an integer. So what we did is, we included the fractions with the integers and we called these numbers as rational numbers. Now, rational numbers were closed under addition, subtraction, multiplication and division. So all the 4 mathematical operations were closed under rational numbers, and hence for a long time it was believed that rational numbers were the numbers that represented the entire number system, because all the mathematical operations were closed under this number system, which is the rational numbers. Now people started using different operations in rational numbers. So they started finding squares of numbers. So this squared 1, which was 1. They squared 2, which was 4. Squaring 3 gives me 9. But now we had found numbers between 1 and 2 also. So what they did is they started squaring those numbers also. So we know that between 1 and 2, we have 1.1, 1.2, 1.3 till 1.9. So squaring these numbers, they found that this is what they get when they square these numbers, these rational numbers between 1 and 2. Now what they observed is, after 1.96, 1.4 square gives them 1.96, but 1.5 square was giving them 2.25. So they wanted to see what number when squared gives them 2. That is, what number when multiplied to itself would give them 2. So this was a question. Well, Greeks answered this question. They actually found a number which when squared gives us 2, and they called this number as under root 2. Who discovered this under root 2? It was said that Pythagoras, the famous Greek mathematician, he was credited with this discovery. But some people say that one of his students was actually the one who revealed this number. So this number was called under root 2. And it was said that under root 2 when squared gives us 2. So now the question was whether under root 2 is a rational number or not. So can you answer this question? Let us say that under root 2 is a rational number. If under root 2 is a rational number, then I can express this rational number in the form p by q, where q would not be 0. If q is not 0, then I can express this number p by q in the form p by q, that is a rational number. So now what we know is that under root 2 is definitely not an integer. Since it's not an integer, under root 2 is not an integer. So if under root 2 is not an integer, I cannot say this under root 2 by 1. That means q is not 1. Q is not 1 because it's not an integer. P by Q represents an integer only if Q is 1. Since this is not an integer, therefore Q is not 1. So I get this. Now what I do is I square both these sides. I square both these sides. What I get is squaring under root 2, we know we get 2. And this is equal to P by Q squared gives me, that is P by Q multiplied by itself 2 times. P by Q times P by Q. So this is what I get. Now this can be written as, I know how to multiply two rational numbers. I can write this as multiplying the numerators by multiplying the denominators, which is P times P upon Q times Q. Now P multiplied to itself 2 times is nothing but P square. And Q multiplied to itself 2 times is Q square. So we see that we can write 2 as P square by Q square. Now Q is not 1. If Q is not 1, then Q square can also not be 1. Because 1 squared gives me 1. So Q square will not be equal to 1. So I get P square by Q square is equal to 2, which I can write as 2 by 1. But Q square cannot be 1 because Q is not 1. Q is not 1. Therefore, Q square could not be 1. So I cannot express under root 2 in the form P by Q because I get a contradiction here. Since under root 2 cannot be expressed as P by Q in this form, hence I can say that under root 2 is not a rational number. So we know that under root 2 is not a rational number, and a number that was not rational was called to be an irrational number. This is how we can say that under root 2 is an irrational number. Now irrational numbers, when they tried to convert an irrational number into decimals, what they saw was that the digits do not terminate. It's a non-terminating decimal. But with non-terminating, what we see is that the digits do not repeat in a sequence also. So let's look at this. We see that under root 2 was this number when expressed in decimals. The digits do not end and do not repeat also. So they keep on going, do not end and do not repeat. So irrationals were numbers that were not rationals. They are non-terminating and non-recurring. So this is what irrational numbers are. This is how irrational numbers were introduced.